chemical bonding. Before we start with all of the questions, you have to know the difference between ionic bond, or also called as electrovalent bond. It is formed between metal and non-metal, where metal atom will donate electron to form positive charge, while non-metal atom will receive electron to form negative charge. Second bond is covalent bond. It is formed between non-metal and non-metal, where electrons is shared equally between these two atoms. The third bond is dative bond. It is formed when a lone pair of electrons is donated to empty, or also called as vacant orbital. So the arrow for dative bond would be like this. The arrow will be go from lone pair atom that has the lone pair to the atom that has the empty orbital. This to show that electron is being donated. Octet rule. Okay. An atom tends to donate or receive electrons until it achieves stable octet configuration and surrounded by 8 electrons in its outer shell. The next thing is formal charge. Okay, put a star on it. You have to remember this. It is the number of valence electron minus the sum of the lone pair electron plus half of the bonding pair electron. So that for the next question number 1, 2, and 3, I'm not going to discuss this, okay, because it's already been explained in the lecture videos. So for the first question, I'll just do the first 3. So the valence electron for 1 would be 1, for 2 would be 2, and 3 would be 3. So the Lewis dot symbol would be 1, 2, and 3. Okay. You continue the rest on. For the question number 2, okay, by using Lewis dot symbol, show the formation of. Okay, for MgBr2, first we have to determine whether it will form ionic or covalent bond. So Mg is a metal, while Br is a non-metal. So MgBr2 will form ionic bond. So this already explained in study guide. Okay, so you try 1 and 2 by yourself. I'm gonna check this in the tutorial. So question 3. Okay, so this already been explained. Okay, question NH4 plus already been explained in lecture video. For question Al2Cl6 and H3O plus, you can draw it based on the information available in your study guide. Okay, the most important thing in chapter 4 is how to draw your Lewis structure, or short form LS. So the first step is to calculate the total number of valence electrons. The second step is to draw your Lewis structure. The third step is to minus the bonding pair electron. Fourth step is to minus the lone pair electron. And the last step, if you got any balance in your calculation, then you have to put all the balance on the central atom. So while we are at this, I want you guys to make some notes. The first note is to Know that more electropositive atom will be the central atom. Second note, hydrogen will never be central atom. Third, lone pair on oxygen and nitrogen will be delocalized. Or in simple form, we can say that it moves around to form double bond to achieve octet rule. Okay, to achieve octet. So let's try to do question 4 together. I recommend you to draw your Lewis structure on another page because this space would not be enough for you to draw your Lewis structure. So for BeCl2, so Be, okay, first we need to calculate the total number of valence electron. Okay, valence electron. So Be would have a valence of 2 electron, and Cl would be 7 since it is in group 17. So 2Cl would be 14 electron. So the total would be 16 electron. So second, draw your Lewis structure. So this is Be and this is my Cl as the terminal atom. The third step is to minus the bonding pair electron. So this is your bonding pair electron, which consists of 1, 2, 3, 4 electron. So in short, one single bond, you're going to draw it like this, right? Carries 2 electron. So for double bond, there would be 4 electron. So 16 minus 4 would be 12 electron. So put this 12 electron around terminal atom in order to achieve octet. Okay, so let's try. So Cl, we already got 2, 4, 6, 8. So Cl already octet. So 2, 4, 6, 8. So this Cl already octet as well. So the red dots or the red electron, you're gonna calculate it as 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. So 12 electron. So this 12 electron is already filled in around the terminal atom for the Cl to achieve octet. So minus 12 electron. So 0. Do we have any valence? No. So we already done at the third step. Okay. You don't have to follow this step one by one. Okay. Just refer to the question. So this is your BeCl2 structure. Let's try I3 minus. So for I3 minus, we have 3I. So each I has a valence of 7. So 7 times 3 would be 21 electron. Minus 1 means we are receiving 1 electron. So the total would be 22 electron. Okay, so draw your I and choose one of iodine as your central atom. Okay, now fill in. Okay, so 22 electron minus how many bonding pair electron? 2, 4. 4 electrons. So 22 minus 4 would be 18 electron. So 18 electron. So this electron, you should distribute it around terminal atoms. So for them to achieve octet. So 2, 4, 6, 8. 2, 4, 6, 8. So 18 minus 12 electron. So we are left with 6 electron. So refer to the rules. If you have any balance, put it on this central atom. So 2, 4, 6. Don't forget to have a bracket because this is a charged molecule. So this is your Lewis structure for I3 minus. Second molecule is CH3 plus. But before that class, I want you to print out this periodic table by yourself because we're gonna refer to their group to know their valence electron. Okay, and please be known that this periodic table will not be given in examination, okay? So you have to remember it by now. So for CH3 plus, for carbon, the valence would be, carbon would be 4 since it is in group 14. For electron, so hydrogen would be 1. So 3 hydrogen would be 3 electron. Okay. Now we have the charge of positive 1. Means this electron donated 1 electron. So positive 1 means we are losing 1 electron. So 4 plus 3 minus 1 would be 6 electron. Next, draw your Lewis structure for CH3 plus. Class, we note that when your molecule is in ion form like this, you have to put a big bracket for all that cover all the molecule and put the charge next to it. So 6 electron. Okay, so second step is to minus with the bonding pair electron. So there would be 2, 4, 6 minus 6 electron. So we are left with none. Okay, so this is the Lewis structure for CH3 plus.